and welcome to the Rochester Museum and Science Center. I'm Tim.
I'm Mark.
And today we're going to be working with
liquid nitrogen.
Yes, liquid nitrogen. Really, really cold stuff that we're going to be using. And Mark, what do you got the liquid nitrogen in?
This is called a doer.
Why do they call it a doer?
Because it does stuff?
Yes, but what's the real reason?
Because a guy called
Doer invented it. Exactly. So first I'm going to put on my goggles, and Mark is going to transfer some of the liquid nitrogen into this other little doer.
That's right. Again, we have to make sure we have to be safe, so I'm wearing gloves. I got my goggles on. I'm going to put some liquid nitrogen into my little mini doer here. Go away.
And now we're going to put some into
the yours? Okay, into the picture here. Say when.
Oh, I'm feeling frisky.
All right.
That's probably good.
All right.
Now, liquid nitrogen. It's really, really cold. And it's,
Problem?
Yeah, look at it.
Oh, it's leaking.
I better talk fast.
Yeah.
All right, well, go ahead. Liquid nitrogen is really, really cold. Now, in America, we use Fahrenheit, and everywhere else in the known world, Celsius. But in science, we also use a scale called Kelvin. That's Kelvin with a K, not Kelvin with a C. And in Kelvin, liquid nitrogen is 73 to 76 Kelvin, which is short sleeve weather if you're Kelvin. But if you're Calvin's cousin Claude in Calgary, Canada, using Celsius, it's minus 196 degrees Celsius. But if you're Calvin's friend Frank in Philadelphia using Fahrenheit, it's minus 320 degrees Fahrenheit. So it's really, really cold.
So what's forming on the outside?
You can see that. Right now, what's touching this picture and everything else in this room right now, Mark?
The air.
The air. So what's forming on the outside here is frost. And that frost, frozen water, it's just like Jack Frost on your windows in the wintertime. It's the moisture in the air condensing onto the picture and freezing. The humidity. The humidity of it all.
Oh, yes.
And right here, here's where the liquid nitrogen is, here's where it was, and right here on the cusp. You don't get to use a cusp word as often as you like to.
Oh, look, it's smoking.
It is smoking. It's what's known as subliming. Something else from the air is condensing, and it's forming an ice here. But you know what?
Is it wet ice?
No, it's not wet ice. It's
dry ice.
It is dry ice.
Hey, what's dry ice made of? Halitosis?
No, but thank you. Actually, it's what we breathe out, which is
carbon dioxide.
And carbon dioxide, when it freezes, it goes from a gas to a solid, or that's known as deposition, and without going through the liquid state. That's why they call it a dry ice, too. And it forms dry ice, and right now it's going from a solid to a gas, and that's known as subliming. So what we're doing right here...
Wait a minute, what's that dripping off there?
You would think there's a hole in our picture, but there's not. What's happening is there's another substance in the air that's actually condensing on the picture, and it's turning into a liquid. If you notice, when it hits the glove, it goes back into a gas. And that is...
oxygen.
Oxygen.
Liquid
exactly.
oxygen.
That's
hey,
liquid
if
oxygen.
we put this over a fire, would it put the fire out?
Well, it's liquid.
Oh.
What does fire need to burn besides fuel?
Oxygen.
So it actually make it poof up a little bit more. Right now, what I'm going to do is I'm going to use this tea kettle. And we use that to make tea. You put water inside, you put it on the stove, you turn the stove on, and you walk away because the watch pot never
boils.
How do you know when the pot is...
This one's high tech. It's got a whistle.
It's got a whistle.
Whistle while you work. Put a little in there. There you go. It's ready already. Woo! Woo!
Right now, the teapot's whistling. And that's because when the water's boiling, it changes from a liquid to a gas, creates pressure, and it makes the whistle blow. That way you know the water's boiling. But actually, the liquid nitrogen right now is boiling.
Or evaporating.
It boils at 73 to 76 Kelvin, minus 196 Celsius, or minus 320 degrees Fahrenheit. Hey, Mark, guess what kind of tea you can make with this?
Iced tea.
2/3 of a pun, P-U.
All right, now, while you were doing all of that, what I did in my little mini dewar was put a ping pong ball into our mini dewar. And what we did with the ping pong ball is poke a tiny little hole at the top. So it's been soaking inside of our little dewar inside here.
There's lots of bubbles
coming up. What do you think's inside the ping pong ball?
Well, the ping pong ball's hollow, so it's got to be air inside there.
So what do you think's coming out?
The air, but...
Well, let's find out. What I'm going to do is I'm going to put it into our semi-sphere here. I call it a semi-sphere because it's not a complete sphere.
No. Who is?
That's right. Okay, so here we go. Here I'm going to do this. Should control a little bit. All right, I'm going to put it inside there. I give it a little swish around. Oh, wait a minute. There she goes.
That was pretty cool.
Yeah.
But why does it do it?
That is a good question. What do you think? Anybody know? Well, this is the reason. Because just like what made this boil or whistle, it was coming out here. Remember we got a hole in it, so what we did was to submerge it. It's just like your rubber ducky in your bathtub. Squeeze your rubber ducky, put it underneath the bath water, you let it go, it actually gets the water inside. This got the liquid nitrogen inside, and then when it comes out into the warm air,
it starts to change from a liquid to a gas. It boils, creates pressure, and it starts to spin the ball around.
That's it.
Very cool. So, there you go. There's our demonstration on liquid nitrogen. Thanks for joining us, and
thanks for coming out today, and we'll see you next time here. Woohoo!